So, welcome to a bonus episode in regard of our Minecraft in Unity series, while I'm still working on the next devlog for our puzzle game. I was thinking that it might be useful for you to have all of our previous 8 episodes compressed into one large tutorial, so that you got all of the important stuff in one video and all of my scripts as well in one single bundle for free. Please be aware that they are in their final version though. Also, please be honest with me if you don't like my idea, as I will literally just put every video next to each other and add some titles to the YouTube part for you. I didn't want to compress it even further, since my tutorials are already notorious for being comparably short, containing only the truly important content. And with that out of our way, please feel free to ask me any questions you got in the comments below, and I wish you best of luck and fun for your journey to make your very own Minecraft game. So welcome to our very first episode of our Minecraft in Unity series. And in this series I would like to show you how to add all of Minecraft's characteristic mechanics to your Unity project. Those being a movable player character, and camera, an inventory system, obtainable and breakable blocks, world generation, crafting, enemies, and perhaps some more. But unlike other tutorials in this area, I would like to put the main focus on the actual Unity development and do the coding mainly for myself. And that's simply because I'm doing Unity tutorials, not C# tutorials. But of course, I will still show you all of my scripts at the end of each of my videos, and try to explain every single line to you. Additionally, I plan to put the scripts that I worked on in each video in its description for you. So today, what I'd like to start with is by creating who in Minecraft is called Steve. And that is our player character with the ability to look around in our 3D space, to move into 4 directions, and with the ability to jump. But before we start, please make sure to subscribe if you haven't already. So in my empty Unity project, all I have is my scene, which is like the 3D environment that I'm currently in, a script called block texture, which will make my Minecraft blocks look as they should be. If you want to have some further information on this, please check out the video, and those 2 scripts that will be important for this video. First of all, my entity script for each like player, animal, enemy and whatever, and my player script that inherits from it, which will control movement, rotation and jumping. Again, I will show you their content at the end of this video. Now to make things look a bit more exciting, I want to create a small like demo scene that will consist of a platform, which is of course not procedurally generated, that will just serve as a small testing area. So I'm going to create a new game object, call this one world, and now I'm already able to create my first block, which will be a cube. I want to shift a bit to the downside, add my texture script to it, and create a prefab out of it, which in Unity are like blueprints that you can later use to create like a whole world of them. Now let's create Minecraft's perhaps most characteristic block, that's the grass block, by dragging that onto a cube. Like that. I'm gonna drag this folder to my root folder. Now if you don't mind, I would like to create like a small platform out of these and make this one a new prefab, more precisely a variant of my like default block. In order to save on performance, I would like to tell Unity that it's able to connect the meshes of our blocks together, like that. Now as a Minecraft player, your eyes still probably already hurt by seeing this, but don't worry, we'll be adding dot blocks to our game later on, so that does already look pretty neat. Next, let's create our player, which our camera should be a child of, so just move with it. And I wanna raise it to like height 2 compared to our actual player. Now I'm able to add my player script to it, which I will cover later in this video, to add a rigid body component as well, in order to make him fall down. But I want to freeze my rotation on every axis to make him fall down straight, like you're used to it in Minecraft. And finally, let's create a box collider, so that Unity knows where our player physically starts. And that should be 2 blocks tall, like that. I think I'm gonna move in a bit backwards, like that. Now if you downloaded the script, let's start by inserting our camera right here, and tweaking the two sensitivity values a bit. Like that. And let's see what happens. And as you can see, we're able to look around freely within our 3D environment. Again, I will show you the code behind it at the end of this video. Next, let's add movement to our player by setting the speed parameter to like 2. And that should already be working, so let's try this one out. But if you take a look, our camera seems to be a bit shaky when we move. So as you see, even with that you can have some trouble. And that's because our player's box collider does already intersect with our blocks colliders from below. So in order to fix it, we can simply switch from our box collider to a capsule collider, like that. And now that does already come a bit closer to what we wanted to have. Finally, let's add jumping to our player by increasing this variable a bit. And if you're familiar with the channel, you will know that usually I prefer to use raise in order to check if the player is grounded. But this time, I want to do it a bit differently. So what I'd like to do today is to create a small hitbox at the very end of our player, which is a trigger that by intersecting into the blocks sets our player's grounded state to true by leaving it again to false. So let's create a new game object for that. Add a box collider to it and make it as small as possible, like that. And make sure to make it an actual trigger. I'm wondering what our final result looks like. Now that seems to be working. And also, we can't make any jumps in midair, just as we wanted. Now for our script. The entity script is supposed to be the parent script for all of our animals, players, and enemies in our game. And it gives them their basic values for their speed and their jump strength, which we want every entity in our game to have. And it tells them what a jump is, which is accessing the rigid body component, which handles the game object's physics, and then applying a impulse, which is specified through that parameter, because we don't want to have a continuous force, and apply that force to the upside with the strength that we can specify through the inspector. And for our player script, we want to build up upon our entity script, but add our camera movement to it, as well as our grounded flag. Now the start method gets called once, at the very start of the game, and it locks the cursor in the middle of the screen and makes it invisible, as you know from Minecraft. And then what we always want to repeat is to update our camera's rotation, the velocity of the player, and to check if he wants to jump. So in our check rotation function, we set our camera's rotation, which I mostly use the one from this video, which is getting our mouse position, getting the X and Y axis of our mouse, and adding it to our Y rotation variable, because we don't just want to have the change of it. The same goes for the X rotation, but we want to inverse it. And since we don't want the camera to make a looping, we want to limit the rotation between negative 90 degrees and positive 90 degrees, and then apply it to our camera as well as to our player. And what I needed to do is to unparent the camera from our player for a second in order to prevent some shaking, and then reparent it to our player. In our movement function, we got our input axes, which on keyboard will be just like A and D and W and S, multiplied by our speed, and keep the y-axis as it is, since we don't want our player to ascend into the air unlimitedly, and then converting it to the local direction of our player, so that in case he's turned around, W means to go forth from his perspective, but back from the global perspective. Now for our jump, as I explained earlier, as soon as our small hitbox enters the ground, we know that our player is grounded, and if not, he isn't. We want our player to only be able to jump if we're grounded, so if not, we cancel right here. And additionally, as soon as the player hits the jump button, like space, we want him to perform a jump, which I showed you in the entity script. And don't mind about this one, as this structs just to store some attributes of our camera. So feel free to leave your suggestions in the comments on what I should add next to our Minecraft game. And if you want to have some details on how our block textures work, please check out the video, and I'll see you next time. So, welcome to the second episode of our Minecraft in Unity series. Last time we were taking a look at how to create our player character, and since my last video has gained quite a lot of feedback, which I'm very happy about, today I'd like to take a look at how to create placeable and breakable blocks. But before we start, please make sure to subscribe if you haven't already. So in Unity, first of all, I'd like to add two more types of blocks to our Unity project. The first one being a stone block, and the second one the good old dirt block. So in order to do that, I'm going to drag my dirt texture onto this block right here, like that. Put the new material right here. What I want to do next is place a few of them into my game. Next, how about adding a stone layer as well? Alright. And I think that does already look a bit more authentic. And if you want to find out how blocks textures work, please check out the video. And by the way, I need to make some changes to my block texture and to my player script. Now finally, let's be able to break all of our blocks by selecting our base block prefab and adding this block script to it, which you can find in the description, but I will also show you everything in it at the end of this video. Now for each of our blocks, we can specify how long it should take in order to break it, like that. And for stone, I'd like to have 1 second. And make sure to assign this range parameter so a player is only able to break or place blocks within a distance of 4 Unity units. And if we now were to take a look at it, it already seems to work pretty well. And below here, we got our stone blocks, but I find it still hard to approximate where the center of my screen is. So next, let's add this iconic cross ride to the middle of our screen by creating a new canvas, make it render onto our camera, decreasing its distance a bit, and make it scale with our screen size, just like that. Now let's add a new image to it. Assign this one right here. Let's make it a bit smaller and a bit transparent as well. And that's already much better. But I think all of that does still look a bit clunky. So let's add a fresh particle system that shows up when we're trying to break a block. So let's create a new particle system, make it a prefab, let's make it a cube shape, and make sure to randomize its direction. Let's use a new sprite for it, make it like green. And now we can attach it to our blocks right here. And I think that doesn't look too bad for now. But I don't know, there's still something I'm missing. Now what on earth could that be when we're dealing with Minecraft? Well, how about being able to place blocks as well? So I'm gonna disable static batching right here and assign the block that I want my player to be able to cast right here. And as we can see, as soon as I click right, there's indeed our block. And I can choose to attach new blocks at any direction I want, just like that. Now when it comes to the script, in our block script, the try break function is called. Every frame that the player holds left at a block, and it then remembers the time that it last was the case, instantiates the particle system if we have one attached as a prefab, and as soon as the block's breaking time has been passed, we want to break it completely, which means in our break function we want to cancel our particles and remove the block from our 3D environment. And if for some reason we stop breaking the block, so if 100 milliseconds have been passed since the last attempt, we want to cancel out our particles. And in the player script, each frame our left mouse button is being held down. We want to make an attempt to break a block, and if not, we want to reset the timer. And after we press the right mouse key, we want to make an attempt to place a block. Which means, if there's a block that we're currently targeting, we want to make it our breaking block, so that in case we switch the targeted block, we can reset the timer, and then we call the try break function from a block, and depending if the block was already completely destroyed, we want to reset the timer as well. And when trying to place a block, we want to instantiate a new block, and depending on the cube's face that we're clicking, we want to position the block at the respective side of the cube. If you want to have some further details on how this one works, please check out this thread from the Unity forum. And by the way, in our check target block function, we're able to detect the block our camera is currently looking towards by emitting a new ray from our camera. In case it hits something, we want to store its position for our try place block function, but we only want to make the hit object our target block if it's a block after all, and secondly, if it's within our range. So if you want to find out how we created our movable camera, our block textures, please check out the playlist. Again, I will put all of the scripts in the description for you, and I will upload this entire demo project to my Patreon as well. And I'll see you next time. So, welcome to our third episode of our Minecraft in Unity series. This time we were checking out how to make our blocks breakable and how to be able to place new ones, like that. And in this episode, I'd like to focus on how to create an inventory system like you used to in Minecraft, excluding crafting, which I will do at some point in the future. But before we start, please make sure to subscribe if you haven't already. So to start off, I'm going to create a new object to my canvas. If you want to find out how we created the canvas itself, please check out the video. And create a new subgame object, which will be an image, which I can now assign my inventory sprite to, and increase its size to an appropriate level. And now I'm going to attach my inventory script to the inventory object right away. You can find this one in the description, but I will be talking about it at the end of this video too. And now all that's left for us to do is to attach our canvas right here, and our window right into this slot. As we don't want to start with the inventory UI right into our face, right at the start of the game, let's better hide this one for now. So in the game I'm going to press E now, and by doing that, our inventory window gets enabled. We're able to see our mouse cursor again, and to move it around freely as you're used to. Now let's continue by making these slots actually working, and by adding a new inventory item to our inventory. So first of all, to make our slots working, let's create an empty game object. And here we can add our slots. Attach our inventory slot script to it, that I will explain to you later. Decrease its scale a bit, and deploy them right onto the slots of our graphic, and for the other rows as well. And that's it. Now insert these to our inventory script by locking it in the inspector, selecting all of our inventory slots, and then dragging them right here. Next, let's create a separate space for our items and assign it to the item parent parameter. And finally, let's create our first item, which needs to be an image. Make it a bit smaller, and we need to add an event trigger to it with a drag trigger, which we'll call the drag function of our inventory script, and a pointer down trigger that we'll call the corresponding start drag function with the script of our inventory item that we need to add first. I'd like to create a new prefab out of it. So as an example image, I'd like to have this oak planks texture right here that you should know by now. And now I want to add a new text to it to be able to show our item's amount. And I think I'm gonna increase the size of it a bit, change the alignment, make it white, and change its rect scale a bit. There you go. Now I can assign my amount text right here, set a default amount, and for a specific oak planks item, I can already move it right here. Change its name to oak planks. Assign the corresponding slot and vice versa. And next I'm gonna explain these 3 simple scripts to you that make our inventory behave as it should be. If you're not interested in those, you can simply skip to the next section and also find them in the description. So first, our inventory slot does just have a handle to the item that is stored in it. The inventory item script contains these attributes that I was showing you earlier, which is the name of the item, the slot that's currently in, a link to its text component, and the actual amount. With this setAmount function, we are able to update the amount attribute and the display text as well. And with the increaseAmount function, you simply set the amount to the current amount plus the increment. And for the inventory script, besides that stuff that you already know, there are 2 hidden attributes. The open parameter that will be true or false depending if the inventory is currently getting displayed, and the dragged item that, as you can imagine, stores the item that we're currently holding. In the update method, I want to toggle the inventory each time that we press E. If we're currently dragging an item, I want to make sure to render it at the very end by changing its child index, which means its place in Unity's hierarchy. And as soon as the player makes the wise decision to click right, then, but only if the amount of the item that we're currently holding is greater than 1, I want to create a new inventory item, which will be of the same kind as the one that we're currently holding, and it should be stored below the item parent in the hierarchy. We want to add our triggers to it, which means being able to drag and drop it, set its amount to 1, decrease the amount of our stack that we're holding by 1, and drop the newly created item into the nearest slot. And finally, as soon as we notice the player is not holding left anymore, we want to drop the item that we have in our hand. Our toggle inventory function looks a bit more complicated than it is. We take the current state of our window and invert it, and then enable or disable the window, make the cursor visible or invisible, set the open flag, and depending if we're enabling it or disabling it, lock a cursor in the center of our screen. Our start drag function gets called in the first frame of our drag. It assigns the dragged item to our dragged item variable, removes the item from its previous slot, and tells the item that it currently isn't in any slot. In our drag function, we got our mouse cursor's position in Unity through these 3 lines, and if we got a dragged item, move it to this exact position. Then in our drop function, which is by far the longest of all of them, we calculate the closest slot by iterating through all of them, and as soon as we catch one slot whose distance is below the lowest one, we make it our new nearest slot. If our target slot does already have an item stored, we either combine it to one single slot, or if it's a whole different item, put it on top of it, which isn't really what you're allowed to in Minecraft, so we should probably take a look at this one again when making our crafting system. And in case our target slot is empty, we can simply put an item there. Okay, never mind, I just changed it so that in case our target slot is already filled, and it's a different kind of item, or the stack is already at its maximum, then we simply put our dragged item back to the slot that was last in, which is calculated simply like that. We got our target slot variable right here, and each time the script notices that the inventory item is in any type of slot, we assign it to our last slot attribute. And finally, in our add item triggers function, we simply add our triggers for pointer down and drag, since we're initializing our inventory items from ground on. Now, how about taking a look at our final result? And again, you can get access to this demo project on my Patreon. So let's see what happens if I press E. Then our inventory shows up properly, and I'm able to drag and drop this stack of oak planks. And if I click right while holding my stack, then I'm able to drop a few of them into the nearest slot, but only if my amount being held is greater than 1. And by dropping one stack onto another, I'm able to combine it into a single stack. And if I hit E again, we return back into our game. So if you want to find out how we let our player, or how we made our blocks work like that, please check out the playlist, and I'll see you next time. So, welcome to the 4th episode of our Minecraft and Unity series. So last time we were implementing our inventory to our Unity game. And now I'd like to give you an idea on how you can create a simple world generation algorithm to randomly create almost infinite worlds. But before we start, please make sure to subscribe if you haven't already. So in Unity, if you watch my previous episodes, you'll know that I was using a block texture script in order to render my textures to every single one of my blocks. And as it turned out, that was eating heavily on performance, since I couldn't use static batching anymore. So what I did to make it perform a bit better for you, I've created these models in advance in Blender that you already have a texture on them, so that I'm now able to use static batching without any problems. If you want to know how I did that, please let me hear in the comments. So you can create and render tens of thousands of blocks with relative ease. So instead of having to create our world manually like that, we can now delete all of our block instances and add a script to our parent object instead. And don't worry, I will show you my specific script at the end of this video, but you can also find it in the description. And with this one, I can easily type in the matrices that I want, the seed I'd like to have, and my block prefabs right here, where if you don't got any prefab for your bedrock block, you can also use stone or dirt for all of these instead. And now what most of the people would do is to generate the world at the start of our game, but what I personally prefer is to generate it in edit mode, like that, so that I can see how it will look like in advance, make some changes if I want. But it has the disadvantage that all of these blocks instances are not bound to the prefab anymore, so if I make any changes to like this prefab, that won't apply to these blocks anymore, so I have to regenerate the world. And by the way, height refers to Unity's y-axis, which is this axis right here. And as you can see, this one will work for greater world sizes almost as fast as for small ones. But if you're planning to create a bigger world, I would still encourage you to use multiple of them as some kind of chunks, or to watch one of my future videos, as I will improve the whole project over time. Now let's continue by diving into our script. So in case you didn't know, the word custom editor script derives from the editor class, and its only purpose is to create like this generate world button in the Unity inspector, which is done by overriding the onInspector GUI function, drawing all of the public attributes as you used to, and then create this button that, if clicked, uses the word singleton to generate the world, or if we lost the instance, display a warning in the console. To the word script, again I want this one to execute in edit mode, have these attributes that I was showing you earlier, this separated collection of blocks. It contains of these blocks that we were just generating. And in order for the other script to access this one, I want my world to be a singleton that I, on awake, want to assign. Then as soon as you click the generate button, I want to delete all existing blocks, insert the seed to a random number generator, and iterate through a 2-dimensional space, which is like our surface at the very top. Then I want to create the small mountains using Berlin noise. Adding this heat right here makes the Berlin noise like move to the up and to the right, so that it won't be symmetrical from the origin. And then we make it an integer, so that we don't have to mess around with blocks intersecting into each other. Then we create our grass block at the very top. We create a child object in Unity's hierarchy, and this one should better say dirt position. We want to descend 2 blocks from our grass block and create a line of dirt blocks to our specified position. Then comes the same for our stone blocks, but with the difference that we want to make them stop at a certain height, which is our height specified in the inspector, plus 1 to the top, so we still have enough space for our bedrock layer, which we then instantiate right here, line per line. Creating a block line looks as follows. We got our starting position, our target position, and the block that we want to have there. And as soon as we didn't reach our target position, we increase or decrease our current height. And as these 2 lines are at the very top of our do while loop, the very first position will be excluded. And then we create the corresponding block, as mentioned previously. How we clean our old word when generating is by removing the very first block of the world's child blocks until there are no more, and we use destroy immediate to make it work in edit mode. So let's take a look at the current state of our game, and from what it appears to me, all of our game's mechanics are working as they should. I'm not sure if you noticed, but our player's movement has become a bit smoother since I was adding this physics material to it. So if you want to get access to this whole demo project, please check out my Patreon. And if you want to find out how we created all of our other mechanics in the first place, please check out the playlist, and I'll see you next time. So, welcome to the 5th episode of our Minecraft in Unity series. And a few days ago, we were discussing how an algorithm for root generation could possibly look like. And this time, I'd like to show you how you can include the mechanic that I think Minecraft is very iconic for, and that is its drops. For example, when breaking blocks that at the end of this video you will be able to collect, and they will be added to your inventory accordingly. But before we start, please make sure to subscribe if you haven't already. And although we're taking a look into 7 different scripts in this video, the amount of lines that we're actually about to discuss will be relatively small. I will show these lines at the end of this video for you, but in order to make it as easy as possible, I will also put the given scripts in the description for you. Now, one thing that you might be happy to hear is that I was able to easily tweak my word generation algorithm a bit in order to create trees right away. So if you're using the script from the description, you simply select your world, game object, head over to blocks, and add the block that you want to have for your logs and for your leaves right here. If you want to know how you can easily create those, please check out the video. And with this slider, you can regulate the amount of trees that you want to have. So let's see what happens as soon as I hit this button. And that's already it. Looks pretty similar, am I right? Again, if you want to know how this one works, please take a look at the end of this video. And with those guys, your overall experience might already be a bit more immersive than before. Now, in order to make your blocks actually spawn drops, the way that I like to do it is by creating this items folder that contains this script for a scriptable object that I can create by going to assets, create, scriptable object, and then item. And now you can easily create one scriptable object for each destroyed block version that you got. So I'm gonna have one for dirt, oak log, and cobblestone, as I don't want my grass blocks to drop real grass blocks, but instead dirt, and my oak leaves I don't want to drop anything. So what I can do now is to enter their name right here, their inventory sprite right below it, and finally their 3D model, which we'll then use for the drops game object. So now you got one folder for your games like most important content. And if you already want to add these scriptable objects to your blocks, you can do so by putting them right here. And again, I want both my dirt block as well as my grass block to drop a dirt block. For bedrock and my oak leaves, I want to leave this one empty, and for oak block, this one will be mundane, and for stone, a cobblestone. Now the only thing that we're missing is an actual prefab for a game object that will be instantiated into the world upon the destruction of a block. So in order to do that, let's create a new empty game object, make it a prefab. And what we want this one to have is a box collider, a rigid body component to make it fall to the ground, and our drop script right here that will automatically add the respective block's model right here, depending on which block the user destroys. And for collect distance, I'm going to use 1.5 right here. And like we're used to in Minecraft, I want my drops to be a bit smaller than the blocks in my environment, just like that. And now, if you're having a base block prefab that all of your other blocks inherit from, or there are like prefab variants from, that is what it's called in Unity. The easiest way to add your drop prefab to every single of your blocks is by just doing so with your block base prefab, like this. So before we take a look at it, don't forget that you might have to regenerate your world in order to apply all the changes to every single block. And now as soon as I decide to break this grass block, you can see that the drop has been created accordingly. And for these leaves, there isn't any drop at all, it's just as we wanted. And for the logs, it seems to be working as well. But if we now get too close to our drops, you can see that we got an error, and that is because we didn't yet set up like the inventory part of this episode. So in order to make our inventory handle collecting blocks, let's open this one up and select our inventory game object, where we can now put every slot that isn't a crafting or armor slot right in here. So we don't want our script to consider using armor or crafting slots to deploy new items. And here we can calmly assert our item prefab, and that's almost it. Except for one thing, we need to assign our inventory right here at our player script so that our player is able to communicate to his inventory that a block has indeed been picked up. So let's give this one another try. And as you can see, this one seems to work a bit better now. And what happens if I open my inventory? Then I've got my dirt block right here. And it seems to work just as fine as my pre-generated one. And as I've been farming a bit of cobblestone lately, doing our standard inventory stuff, seems to be working as well. So before I lose myself in this cave, let's continue to the section that I've been looking forward to today, and that is our scripts. Now first, for our world generation, the only thing that's been changed is that we now got this tree probability attribute right here, displayed in the editor through a slider, and a new block within our prefabs struct. Oh well, it seems to be two blocks, never mind. And that are the ones for our trees. Now, in our generate function, if you're having a loop that iterates through our world's two-dimensional surface, you can simply check at the end of each vertical block line if a random float that you want to generate between 0 and 1 is within your tree probability. As if we choose 0.2 here and generate a float between 0 and 1, the chances are 20% that our script will create a new tree. And as we're dealing with a fixed seed right here, this one is going to produce reliable results for you. Now generating a new tree then looks like this in our create tree method. First, we want to create a new line of logs, which is going to be our log, and it should consist of 4 blocks to the upside. If you want to find out how this one works, you will find that information at the end of my previous video regarding the series. And in the following, we want to create a whole lot of trees, or more accurately, one for each of these relative positions, where all 0 refers to the block that's directly under our first log block. And since these are relative positions, we need to add them to our init position right here when instantiating our new block with this default information about its position, orientation, and its parent in Unity's hierarchy. The item script contains the information about our item's scriptable objects, which we want to have a shortcut to at Unity's top navigation bar. And all we got here is a reference to the object's name, which will be used to compare the different block types in the inventory, the items right for the inventory, and the item's model when appearing in its drop form. Now this drop script is the only thing really new, besides the item script containing the collect distance together with this information that's going to be assigned by the block script on creating this drop. Now, if the block script did already define the model prefab, then you actually want to create the 3D block object below this drop prefab within our init method. In our update method that is continuously getting called, we want to locate the player through its tag. And as soon as we got it, we want to check if he's within our specified distance, and if so, collect the item that's been dropped, which means in our collect function, getting access to the player again, and then calling its getItem function and destroy this drop, as we don't want our player to pick it up multiple times. For our block script, we got our new things right here, and compared to our previous video, as soon as we break the block, we want it to drop its item, which looks as follows. If we didn't assign any item, like with our leaf blocks, we cancel right away. But if you do want to create any drop, we do so by instantiating the drop prefab at the block's position with its normal rotation and assign the respective model and item name. As discussed previously, for our player script, there is our new inventory reference right here and our getItem function that just passes the call to the player's inventory. And in our player's inventory, we got our baggage slots right here that can be used to store newly collected items, and our item prefab right below it. Now right here at the very bottom, we got our new function, which checks if there's already a slot in the inventory with the same type of item. So we iterate through all of our slots that we care about. If there isn't any item, we don't want to add our item here. If there's a different item, we don't want to do so either. But if there's item of the same type, we want to increase the stack by 1 and disable this code right here from being executed, which, if we didn't find any known slots, we'll iterate through all of our important slots, just as the snippet above, but this time we want to continue until we find our first empty one, and if so, create a new inventory item from a prefab, place it into the right slot, make sure to update its item name, set its sprite as well, link the item to its slot, and vice versa, and add its triggers, which will then be used in order to handle drag and drop. Again, please check out my previous videos for more information on this one. And finally, in our inventory item script, the only thing you don't know by yet is our setSprite method, which won't be very difficult for you, as it just gets access to the inventory items image component in the inspector and setting its sprite to the one that we want to have. So if you want to get access to this whole demo scene, please check out my Patreon, and I think that's how easy it can be in order to handle drops, like in Minecraft, including every important detail there is. So if you want to find out how we created this inventory in the first place, please check out the playlist, and I'll see you next time. So, welcome to the 6th episode of our Minecraft in Unity series, and last time I've been showing you how you can introduce drops to your Minecraft game. And today I'd like to focus on crafting, which means that I will divide this tutorial into 2 sections. The first one focusing on being able to craft items in general and how to set everything up. And the second part will be how to create the workbench and like the default crafting UI that you all know and love. But before we start, please make sure to subscribe if you want to get notified on our new features. So I've come up with a way that makes adding craftable items pretty easy. So let's go into our items folder that contains the scriptable items for all of our important blocks. And as you can see here, this resub tab has been added with the items that will be required in each slot. Maybe one thing, you can get all of the scripts that are important for this video for free in the description, but you can also stick to the end of this video where I will be explaining them in detail. And if you don't mind, I'd like to, instead of uploading my scripts to Google Drive, would prefer to upload them for free to my Patreon, so you got them in a timeline and you don't have to keep track of all those links. And I'm also planning to give our supporters, regardless of which tier, anticipated access to them. So now let's say I want to add oak planks that can be made out of logs. Then I can just duplicate this one, change its name, its inventory sprite, and then I'm gonna drag my oak log scriptable objects into top left. And that's already it for the oak planks. So I'm gonna create one for our workbench as well, with its model right here. And for its reset, I want the player to put oak planks like in the top left square of the crafting grid, which would then look like this. And now all I have to do is to go to our inventory, game object, like that, lock this inventory inspector tab, and assign the slots that are responsible for the crafting, these 4 right here, at crafting slots. Now I'm going to create a new slot that should contain our output item and assign it right here. And now for each item I want this crafting section to be able to craft, I need to insert the respective scriptable objects right here. Now let's check out if it's working so far. And make sure to add your inventory UI right here at UIs in the player script. So later on it can make sure that none of the UIs overlap with each other. And I need to add my newly created output slot to my slots list as well. And now if I were to chop this tree, I got my drops right here, like in the previous episode. If I now drag those into the top left corner, you can see that I'm indeed able to craft these oak planks, just like that. And if I try to make a crafting table, that seems to be working as well. Great. So now secondly, let's continue by creating our workbench. So I'm going to open my blocks folder and create a new prefab variant out of my base block, like that. Do some business as usual by adding my workbench model to it. But now, unlike the other blocks, I want to remove my block script and add this specialized UI block script right here, that, as you can see here, derives from the block script as it shares some of its public attributes. I want to be able to break it within 1 second, make it emit brown particles on destruction, put my drop prefab right here, assign my scriptable item right below it. Now this is where it gets interesting. Here I can input the tag of my crafting UI, like that. The tag will be like this one. And the reason why I did that is to make it as easy as possible for you, as you can use this UI block that will open a UI on click for many of your feature blocks as well. Like if you want to create like the anvil or Minecraft's enchantment table, you can use this one as well. But since we're unable to place other blocks despite the grass block, and I want to put this manually into our world, like that. And now for its UI, I think I'm gonna go on by duplicating my inventory UI, replacing the inventory script with this crafting script that derives from the inventory script. Insert my normal values right here, and of course it should have the right sprite applied to it. And now, unlike my inventory UI, I want to put my crafting slots right here onto this grid from our graphic, make some new ones, fully cover it, and put my output slot right here. And now adding the slots, and the output slot will be the same, but our crafting script will require a reference to our inventory in addition. I don't want to forget to add my craftable items right here. And the reason for the inventory reference is that I found the easiest way to handle this crafting UI that uses the inventory is to just copy and paste the inventory right onto the crafting UI. And as soon as you make some changes, apply those changes to our inventory as well. So finally I'm gonna disable this window again and try everything out, and add our crafting UI to our player's UI list. And finally I want to change the tag of my crafting UI to crafting, as discussed earlier. My crafting UI opens, and I can see my inventory at the bottom of the UI. If I make some changes here, I can see them affect my normal UI as well. I'm able to craft just as I wanted. Maybe one thing, if you're putting items in the crafting grid at the moment and leave the UI, they won't be dropping out, and instead they will be vanishing. If you're finding it very hard to do that yourself, I can make another video on that if you want. If not, I would probably do like the tool belt or enemies next. And now to the thing that I'm probably already notorious for, and that is our scripts. Maybe to start with the short ones to warm up a bit. This UI script I made as a base script to make our inventory derive from it. So I just cut out this toggle function from my inventory together with the window attribute and the open flag. So you can use this one like for your main UI as well. Then our inventory item script, where I just added a reference to the scriptable item to give like our inventory whatever access to some data other than those like the sprite, and this public but hidden just crafted flag, so that later on our inventory knows if it can delete the item in our output slot in case the player takes out the items off the crafting slots. Then our newly created UI block, like for the workbench, it has the UI tag string and the inspector, and as soon as the player interacts with it, we get the game object with the corresponding tag, get the UI component, and set it active. To the player script, on the other hand, we got our new UI array right here. I made one minor change to the check rotation function, which now emulates the rotation if any UI is open. We get to this function in a minute. The same goes for our check jump function, which now cancels if any UI is open. Then if we're trying to place a block, like by holding right, then we now check if we're dealing with a UI block, and if so, we want to interact with it by opening its UI, and make sure to return right here, so we won't be placing any block besides it. Our UI open function iterates through all of our UIs in the array, and as soon as a single one of them is open, we quit this function by returning true, and if not, false. And yeah, instead of checking whether the player wants to open the inventory in the inventory script, we now do that in the update method of our player script, and it says try, because we only want to activate our inventory if there's no other UI open, which we check by iterating through all of our UIs, ignoring our inventory this time. This one will filter out all of our UIs that are already closed, and if we catch a UI that is open, we close it and set other UI open to true, so we don't open our inventory at the same time. Our item script is our scriptable object, which now has one object of this struct type, recipe, which contains another item in each of the slots. And for the first time on this channel, we want to redefine our equals operator, so we're able to compare two different recipes, and they should be the same, only if every single of the slots is the same right here, and if a single one doesn't play like to our rules, we immediately return false. This is the opposite, so we return true if both of the recipes given are not the same. And these two are just default functions that you need to use in combination with these. To our inventory script, again it now derives from our UI script and doesn't have the toggle function in its update method anymore. Instead we got this check recipes function, which converts our crafting grid into a recipe, and for each of the recipes we attach in the inspector. We check if they're the same. If so, we need to make sure that there isn't any item in the output slot already, and if that's also the case, we instantiate a new item with the data from the scriptable object, like the name, the sprite, and so on, within the output slot at our drag and drop triggers, together with some additional stuff that I'll be showing you in a minute. And we set our just crafted flag to true that we talked about at the beginning. Alright, so I just needed to make two quick changes by adding this recipe successful tag right here. That will be set to true if one of our recipes is indeed craftable, because if we have, however, find out that none of our recipes is craftable anymore, because the player removed one item from our crafting grid, and we still got the output item in the output slot, and has just been crafted, so the player didn't put it there manually, we want to make sure to remove it again and clean the slot, so that the player isn't able to duplicate things. Next up, our grid to recipe function works as follows. We create an empty recipe, and if we're dealing with 4 crafting slots, like in our standard inventory, we want to put the first item into our top left slot and so on. But of course, But of course we have to make sure for each single of our slots that there's actually an item in it. And then we quit this function by returning our recep. If we're dealing with 9 items, like within our workbench, then the first item will be the top left one, then top center, and so on. Our add output item triggers is pretty much the same as our add item triggers, and it does also add drag and drop right here, but in addition to that we add a new function that is called start output drag. It is defined below here. It sets just crafted for the item to false, removes all the triggers, and adds the default once again, so basically so that this item doesn't count as the output item anymore. And then for each item in our crafting grid we want to consume one of them. If it's the last one, then we want to destroy the item used for crafting completely. This instantiate item function I made to save some space, to make it a bit easier for you. It just instantiates a new empty inventory item below our UI. In the hierarchy assigns the corresponding values and assets and the slot and vice versa, and returns the newly created item in case we want to do something with it right away. And last but not least, our crafting script, which is a modified version of the inventory. As I said, it copies the inventory at the beginning using the paste function that you will get to know soon. And as soon as we make some changes, means if we drop an item, we do the whole thing the other way around. So instead of pasting the inventory slots, except for the crafting slots, to the crafting UI, we paste the crafting UI's package slots to the inventory and do all of the stuff that inventories code-wise need to do by calling the same function of the base class. And our paste function, by the way, looks like that. We got the slots that we want to paste. Then we remove all of the items through our clear function, which iterates through all of the slots. If there's an item in it, we want to destroy it. And just to be sure, set the item to null. And then we iterate numerically through all of our paste slots. And if it has an item, then we continue right here. We instantiate a new inventory item, which should be the respective one of the paste slots at the corresponding slot. And it then, as always, sets the right amount and adds all drag and drop triggers. And that was the entire list of what we managed to achieve today. If you don't want to set all of this up yourself, please check out my Patreon. And I'll see you next time. So, welcome back to our Minecraft in Unity series. Last time we've been discussing how you can add crafting to your Minecraft game. And in this episode, I'd like to teach you how you can add Minecraft's iconic hotbar to your game, which is like this kind of inventory snippet that you got at the very bottom of your HUD. But before we start, please make sure to subscribe to stay up to date on our progress. So what I've prepared in advance for today is these two sprites. The first one being a slot for our hotbar, and the second one the corresponding selection tool that we're gonna call selector. So first, let's open our canvas and a empty game object for our hotbar, and add a new hotbar script to it, or simply take the one that you can find for free in the description. Next, let's add an empty game object for our slots that contains a horizontal layout group that aligns in the middle center. Now we can add a new image with our slot sprite attached to it for each of our slots, like that. So now we only have to increase the width of our horizontal layout group and set the anchor of our hotbar itself to bottom center, and let's pivot as well, so we can now make it align to the bottom of our screen by changing its Y position to 0, like that. Finally, if you've been following my tutorials, make sure to add an inventory slot script to your slots as well. And now we can add them right here to hotbar slots. As you will see in a second, I've made this script very simple, as you can simply select your inventory slots you want to copy and drag them right here, and these will then be mapped onto our hotbar slots. Next we can add the prefab for our inventory items right here, and add another empty game object to a hotbar that we can store our items at, and assign it right here. But somehow I'm still missing something, and that is our selector. So let's make our selector a new image with the correct sprite, which should be this one. And to make it a bit more authentic, I will increase the size of it a bit. Just like that. And the only thing that's left to do for our hotbar is to drag the selector right in here. And right off we go. And by using my mouse wheel, I'm now able to switch the selected slot of my hotbar. Dragging an item from my inventory, like right here, will indeed cause my hotbar to display it accordingly. But if I now click right, I'm not able to place any blocks anymore. And the reason for that is that my hotbar script will automatically enable you to change your active block for placement as well. But in order to do that, we have to do a little bit of setup. And in this case, setup means to go into the items folder, if you've been following the tutorials, and assigning the corresponding block prefabs in this block field for each of the items you got. And this block prefab will then be assigned to the player's active block on movement of the hotbar's selector. And don't forget to assign the hotbar as a whole to hotbar on the player script. And now even if I decide to craft those into oak planks, I'm able to place those right here, and their amount decreases until I've used all of them. And now I think we got everything we need in order to take a look into the scripts. So regarding our item scriptable object, the only thing that's changed is this block reference right here, which our item object used to tell the player which placeable block the scriptable object is assigned to. Inside our player script, we now got our hotbar right here, and on the other hand, the active block field is now hidden, which doesn't really matter, but I don't want myself to intervene there. In the try place block function, and I want to quit here and don't execute the rest if there aren't any blocks left, which means active block is null, and if I manage to place one, I want to decrease the block that's selected. Finally, let's continue to the hotbar script, which has these inspector values that you saw earlier, and in the update method that's continuously getting called, we paste the inventory slots that we want to copy from the inventory to the hotbar and check if the player wants to move the selector. The paste function itself looks like that. At the beginning we want to remove all of the copied items and then copy them anew. Iterate to all of the inventory slots that we assigned right above here. If it actually holds an item, we want to instantiate a copy of it for our hotbar and place it at the correct slot and copy its amount as well. Clearing the hotbar looks like that. Reiterate to all of its slots, and if it holds an item, redelete it and set the item attribute of the slot that had held the item to null. Instantiating a new item looks as follows. We instantiate a new game object out of our item prefab with our item parent as its parent, then set its position, its sprite, to what's given from the scriptable item, its name, scriptable item, and finally assign its slot and vice versa, and then return it. When it comes to our selector, we check whether the mouse wheel has been rolled upwards, then we decrease the integer that refers to the selector's position by 1, if possible, which means if we did reach its end already, and by scrolling the mouse wheel downwards, we want to move right with the selector. Depending on the selected slot index, we get the position of the hotbar slot with the given index and assign it to the selector. Then we want to notify our player that his block held has been changed. Of course, if there isn't an item in the slot, we don't. But if so, we try to find the player using the player tag. If we weren't able to find him, we cancel right here. But if we manage to find him, we access the block prefab of the scriptable item of the slot that's selected again and put this into player.activeBlock. And finally, decrease selected item is called each time the player places a block successfully. Then we access the inventory item and call its increase amount method. And since this one is for increasing and this for decreasing, we need to put a minus in front of our decrement. And this one we should already know. Does just change the amount variable of the item and update its UI text. And if the amount of the exact same item reaches 0, we want to remove it and tell its previous slot that it has been removed. And just like above, we try to find the player by its tag. And if that was successfully, we set the player's active block to null. And that's all we wanted to do today. If you want to get access to this entire demo scene, please check out my Patreon. And I'll see you next time. So, welcome back to the next instance of our Minecraft in Unity series. About a week ago, we were creating our hotbar, and today I've prepared something special for you, and that is how to create enemies like in Minecraft. Maybe one more thing. This will be the final episode for now, at least. I do have 2 awesome things in the pipeline for you still regarding this series, but unless there's demand for some other features, I think we've got all important stuff covered now. And you can find the finished version of this project on my Patreon now. But before we start, please make sure to subscribe to stay up to date on what we got in the pipeline. So, last time I was using a separate video in order to explain how we created all the assets, but this time I want to show you how you can create a 3D model of your preferred enemy right away. That's why I will show you how to do that in Blender in the first section of this video, and obviously you can also find a lot of stuff regarding Minecraft's 3D models online. So in my empty Blender project, the first thing I did in order to create the zombie was to remove everything but the default cube, pressing tab to enter edit mode. If you want to make the actual modeling a bit easier for you, you can use the mirror modifier, but then UV editing will be a bit more difficult later on. And you can select through the faces tool the top and bottom face and increase their scale on the Z-axis like that to create the legs. Maybe duplicate it. And I would encourage you to create a new cube while in edit mode, which will make the weighting of the rigging a bit easier later on, since our zombies' movements will then look a bit more authentic. And by the way, these movements I do through the G key on my keyboard. If I want to select the total arm, I can also enter wireframe mode and select all of these phases at once. To do the UV editing, I prefer to enter shading mode. Then I got my workspace like that, where I can just drag my texture in here like that, and connect color and base color. And as soon as I now select a face of my zombie model and select the corresponding texture right here, and make this the UV editor, I will see it like that. I can drag it right here, change the edges a bit, and let's better rotate this guy like -90 degrees. And as you can see, I only did the front part now. It really isn't the prettiest zombie of them all, but maybe he'll take it as a compliment. So next I'd like to return to modeling, hit tab again to enter object mode, and add a new armature. Maybe switch to wireframe shading, enter edit mode again, and then let's drag this bone all the way up to the top using G, and then with the E key we're able to add new bones to it that can form our skeleton as a whole. Like that. And we got our good old head bone right here. To connect these two though, we'd have to first select our model, then shift select our armature, and then click right, parent with automatic weights. However, if I now choose to enter pose mode, need to move one of our bones, I can see that the according shoulder is getting deformed strangely. And by moving the legs, one part of his stomach does move with it in an unhealthy way. And that, as you could have guessed, is because of our zombies' weights right here, where we can decide which parts of our model are getting affected, how much by each bone. So in this case, I'd like to click right, drag this one right to 0, and then paint all the way over those vertices, and for the shoulder, make it entirely blue. So let me return to pose mode real quick, and now if I move this one and this arm as well, that does look way better. And now we got everything we need in order to go to File, Export, and I personally use FBX. Make sure to have your zombie texture in your Unity project as well. And personally, the settings that I always use is setting path mode to copy and selecting this one and reducing the scale. Well, doesn't really matter, but I usually use 0.5 here. And if we now take a look into our Unity project, our zombie is waiting for us right here. And with that, that's already it for the first part of the video. Now in the second part of this episode, gentlemen, we need to convert our zombie model to a prefab in Unity to either be able to instantiate it at runtime, for example for your day-night cycle, or to instantiate it manually and like having centralized control over it. So in order to do that, let's create a new empty game object, drag it into your Explorer and open it in prefab mode, and then drag your model right here and let's decrease its size a bit. And I think 0.2 is what I had when testing. Then you can add your corresponding script or use the one you can find in the description. I originally planned to make the enemy script inherit from, or to make a separate zombie script and inherit it from the enemy script, which I, on the other hand, inherit from our entity script. But instead of doing that, I've just tried to make the enemy script as general as possible, so you can use it for almost any kind of enemy. So I will now enter a few values right here. By the way, target range means the distance to the player that our enemy is trying to achieve. Like this guy, for example, if you ask him, he'd probably want to make the distance between your brain and his teeth to 0. But when it comes to skeletons, for example, since they're ranged enemies, they'd probably want to keep some distance to you. And then, but I won't be showing these in this video, but you got also some options to consider right here for ranged enemies. Here you got your animations. Speaking of animations, let's add the first one. Enable automatic keyframes. And one thing I even wanted to before is to make sure that this guy has its hands up, even if in its default state. So finally, for the walking animation, let's say I want to start it like that. 1 second later, switch the rotations, and at the end, I want to have the same state like in the beginning. And since I don't want this to be the default state, I'm gonna create an empty state, idle. Make sure yours is called idle as well. Make this one the default state, and that's it. Next we'll need a rigid body component and a capsule collider that you can simply change manually through this button. Yeah, like that. And this is pretty handy for me now. This ray you can see right here, the zombie or whatever enemy you got will automatically jump onto every object that is located like within this ray that does have a block tag to it. So if you're having a similar setup like we do, make sure to add a block tag to all of your blocks and to regenerate the world. Now let's drag this guy into the thing like that. And now let's take a look at how our undead friend is doing. And before we do it, we need to insert our animation right here. There he is, working. And also we need to make sure to freeze his X and Z rotation, like that. So there he is again. I'm gonna go a bit towards him so that you can see me. And he is jumping lovely onto the blocks. And will indeed try to touch me, which works as you can see in the console. If I get too far away again, then we'll start to wander around again aimlessly. Again, if you're planning to make a ranged enemy, you can make this the range from which your enemy is going to start shooting. This will be the seconds that pass between each and every shot, and your actual bullet that will on instantiation automatically be rotated towards the player, but only once. So next, let's bite the bullet and take a look into the world of code, shall we? So today we only really got one script, yay, which is our universal enemy script, deriving from the entity script that you should already know by now. Provides us with some basic attributes and the jump functionality. The enemy script, however, has its attributes you already know right here, and then some floats to calculate the time that's passed between the last of these actions, and this one for its idle state in which the enemy is just going to wander around. Our start method is just a simple slave of ours in order to assign our components, but in our update method this will be quite important. We locate our player through its tag. As soon as we found him, we check if we're able to see him. If so, we want to move towards him, but only as long as we didn't reach our target range yet. Then we rotate our enemy towards him, except the y-axis, so that the zombie doesn't clip into the ground or whatever. And then move towards him, play the walking animations, and in case we're facing a block, jump on top. And if we did already reach our target range, we play our idle animation. This will be for your skeleton. If we're in shooting range, we take a look if enough time has passed since our last shot. If so, we register this one as our latest shot and instantiate an error and rotate it towards the player. If our player isn't in our view, on the other hand, then we calculate a new random direction every 10 seconds, and for the first 6 seconds in this time frame, we're moving along our random direction and do the usual stuff. In the last 4 seconds, we do nothing. And yeah, as you see, I was using some magic numbers here. I just thought you can change those at any time anyway. If you watched the video, you know. And yeah, I just don't want to get the Unity inspector all messed up, unlike what other developers might be doing. Yeah, check jump. Again, that is what we do if we're moving. We don't want to boost ourselves in the air, so we perform this only once each second. And if our ray that we shoot in front of us does hit something, if not, we cancel, and it's a block. Then we register our jump and jump, which is provided through the entity script that you can find in the description as well. And this one is for deeper purposes, which is an actual visual ray of what happens under the hood. And finally, on a collision, we just want to know if it's the player, and if so, yeah, you can do any stuff you want, but I'd encourage you to decrease a health variable that you add to the entity script, which does then automatically call a dive function that you'd probably want to override for the player, since you just don't want him to just disappear. Instead, you probably want to display your death screen and whatnot. And with that, I think you got all you need. Again, feel free to check out our Patreon if you want to get access to this whole scene, or simply subscribe if you feel like it, and I'll see you in the next series.